Okay, so today we're going to look at Venn diagrams. You guys have heard of and used Venn diagrams before. We're going to apply them to some geometry and math concepts, so that's what we're doing today. All right. First, a Venn diagram. Okay, Venn diagrams are an illustration of how a set of things that satisfy the hypothesis lie inside the set of things that satisfy the conclusion. Okay, it's a visual representation of our conditional statements. All right. The hypothesis always goes in the small circle. The conclusion always goes in the large circle. All right. So far, so good. So, if we want to draw a Venn diagram for the following statements, if it is a fish, then it lives in water. Well, the hypothesis is the animal is a fish. The conclusion is it lives in the water. So if we were going to write that out, and you can abbreviate and make things, make things shorter or whatever, as long as it's legible, okay? So if we just had fish and then lives in water, okay? It can really be just that simple. So if it is a fish, then it lives in water. And you'll notice that the circle inside here is small because the fish obviously isn't the only thing that lives in water. So it's just a part of the group. Every cat has a tail. So write a conditional statement from every cat has a tail. So if an animal has a cat, what is wrong with me? If an animal is a cat, fixed it that fast, then the animal has a tail. So there's our conditional statement. The hypothesis, the animal's a cat. The conclusion, the animal has a tail. So again, really simply, all we have to do is cat, tail. No problem, right? If it's a cat, it has a tail. And look, if you want to be a little more specific and you want to write like has a tail, perfect. But we don't have to write out every word. It'll get crowded in there really fast. So draw a Venn diagram and write a conditional statement for these. So I think it's a little bit easier to write the conditional statements first. Okay, so all whole numbers are integers. So if a number is whole, then it is an integer. All right, and then if a polygon is a regular pentagon, then it has exactly 5 congruent sides. Okay, so there's our conditional statements. Now we want to put those in our Venn diagrams. Okay, so down here we can write whole number, and then that it's an integer. And then down here we can write regular, and again I'm abbreviating, pentagon. And then up here I'm going to write exactly 5. I'm going to use the symbol for congruent sides. Okay, so there are 2 conditional statements and 2 Venn diagrams for the given statement. Over here, write a conditional statement that each Venn diagram illustrates. Go ahead and pause the video here. See if you can write the conditional statement for each of these. Pause the video now. Try to do that on your own. All right, so you've unpaused. Let's go ahead and take a look at what you got. If an animal is a gorilla, then it is a primate, something along those lines. Doesn't have to be exactly the same. And if a given number is the number 29, then it is a prime number. So taking a diagram and writing a conditional statement. That's backwards from what we just did. All right, so there's 3 types of relationships that Venn diagrams can show us. The all relationship. So this is like anytime we said like all dogs are animals, like that could be an example. Then we have the some relationship, like some women are moms, but not all women are moms, so that could be a relationship. And then the none relationship, like if we had just, ducks and reptiles, okay? I don't know of any kind of duck that is a reptile. If you do, tweet me a picture of it. So those are the 3 types of relationships that we can show with Venn diagrams. So create a Venn diagram to show the following relationship between the following sets. Pause the video here. Try to do these 4, and then unpause the video, and we will take a look at them together. So pause the video now, please. All right, you've unpaused. Let's take a look at what I got. So for dogs, puppies, and animals, I got this relationship. All puppies are dogs, and all dogs are animals, and all puppies are animals. So I got 3 circles like that. You can have more than 2, obviously. Basketball players, musicians, and girls, I got this. Some girls are musicians and aren't basketball players. Some basketball players are girls and some are boys. And then, so we have this relationship where it could be any sort of overlap. All right. Rabbits, bunnies, wolves, and mammals. I got this. Bunnies are rabbits, and wolves are not. But all three of those groups are mammals, so they're all inside the big mammal circle. And then I think this is the hardest one. Sons, fathers, and grandfathers. All grandfathers are fathers, and all fathers are sons. So this one looks like that. If you have questions on any of these, put a star or something on this page, and then later, when we have time, ask me a question. But if you got questions here, put a star or something. I think this page can be difficult, so put a star or something, check, hearts, something, so that you know to ask questions on this page later on. All right, so representing data using Venn diagrams. So we can answer questions given a Venn diagram with numbers in it. So it's not too hard. I just need you to concentrate on what you're looking at and focus on what it's saying. So how many girls play both soccer and volleyball? Well, soccer and volleyball. How many girls play both? Well, these 10 just play soccer. These 6 over here play soccer and tennis. These 2, they play soccer and volleyball. They play tennis also, but they play soccer and volleyball. So there's those 2. And then this 1. So those 2 and that 1 added up make 3. How many girls play all 3 sports? That's just the middle one, okay? So just the middle one, so that's 2. How many girls play volleyball? Well, that's not just volleyball. It's how many girls play volleyball. So this 5, this 2, this 1 here, they all count. All of these girls play volleyball, so the answer to that is 20. How many girls don't play any sports? Look outside the sports. Boom, 8. Easy one. How many girls were surveyed? To find how many girls were surveyed, we need to add up all of the numbers inside. So 12 plus 12 is 24. 24 plus 6 is 30. 30 plus 30. Pause the video and add those up. And you got 56. Good deal. Over here, students were surveyed about participating in basketball and soccer. 56 played basketball, 24 played soccer and basketball, 68 played soccer. Draw a Venn diagram of this relationship. All right, so right here we have, and when you label this stuff, it doesn't have to be perfect, but over here I'm going to have, actually let's do this. Let's move that up. But these are basketball and these are soccer. And then we want to label the diagram. So it says 24 played both. My suggestion, start in the middle, okay? Start in the middle. It helps you get these right. Write that down. So let's start in the middle. 24 played both. So there's 24. Then it says 56 played basketball. So this whole circle, okay, this whole thing is 56. I can't put a 56 in there because then 56 plus 24 is 80. And now I'm saying 80 people played basketball, and that's not true. Okay, so I'm going to take the 56 and I'm going to subtract the 24 that I've already counted. Okay, and that's what I put in here. So we have 32. Same thing down here for soccer. It says that 68 played soccer. Well, we've already counted these 24. So 68 minus 24 equals 44. All right, so then we have answers to our questions. Okay, how many played only basketball? No problem, 32. Only soccer? 44. How many were surveyed? Now we add up the 3 circles. So that is 24 plus 44 is 68 plus 32 is 100. Okay. Here, I want you to pause the video. I want you to try to do this on your own, and then unpause and come back to it, and we'll see how you did. Okay, pause the video now. Okay, so here is what I got. I have. And again, I started in the middle. So if your numbers are different, that's fine. Erase them and look at these and make sure I didn't make a mistake. We started in the middle with 15. That was the easiest because that's geography, science, and art, so I can put a 15 in. Then it says 31 have science and art. Well, that means that 15 and then this blank have to add up to 31. So 31 minus 15 is 16. That's how I got that. Same thing here for geography and art. That's how I got 18. Same thing here for geography and science. That's how I got 20. Now, 60 have art. So I go to my art circle and I take 60. Okay? I take 60 in my fancy-dancy calculator. And I'm going to subtract the other 3 numbers. So I know that 60 have art, minus 18, minus 15, minus 16, and that's how I got 11. It says 80 have science. All right? So I have 80 minus the 20, minus the 15, minus the 16, and that's, well, yikes. That's how I got my math way off. Good, let's fix that. Whew. Sorry about that, guys. That was way off. So 60 minus 31 is, make sure, so I don't mess it up twice. 29. Okay, and then the same thing here. I have 70 in geography, so 70 minus 18 minus 15 minus 20 is 17. Okay, so that's how I got those numbers. Now, at the end it says how many of the 200 students surveyed had none of these courses. So then I take the 200 students surveyed and I'm going to subtract each one of these numbers. Minus 17, minus 20, minus 29, minus 18, minus 15, minus 16, minus 11. And I get 74. Looks complicated, but it's really not. Just a bunch of addition and subtraction. Okay? Same thing here. Go ahead and pause the video, and then we'll check your answers to this one. Pause the video now. Make sure you're doing this in pencil so you can erase. Pause the video. Okay, using the same exact method, this is the answer I got for this question. And then at the end, it says, what percent of the students did not turn in any of the problems? Well, I know that I'm going to start with 100% because that's all. So then I did 100 minus each of these numbers, and that's how I got 9. Again, if you have questions on that slide, if you have questions on that, make sure that you're putting, some sort of sign on it so you know to ask questions about that later on, okay? Intersection and union of sets. So Venn diagrams are used to show unions and intersections of two or more sets. They show relationships between sets, okay? So a union is the combination of the sets, and the symbol for that looks like a capital U. And the union of A and B would be the combination. It would be everything that A and B have. The intersection is what the sets have in common. That's an upside down U. And then here in the drawing, what they have in common is just the part that overlaps, all right? So we take a look at this one. We want to know if A is 1, 2, 3, 4, and 5, and B is 2, 4, and 6, then the union of these sets it's just every number. The union is everything. So the union is 1, 2, 3, 4, 5, and 6, okay? It's all the numbers. And I'll even put it in the little weird brackety thingies. The intersection of these sets is just the part that overlaps. So that's, yikes, oh my. 2 and 4. Okay, easy enough. So set L represents Larry's pets. Set L is a dog, a cat, and a hamster. Set M represents Mila's pets. Set M is dog, cat, goldfish, and parrot. So we have L and M. All right, draw a Venn diagram of this relationship. Well, dog and cat, they are shared by both. So I'm going to put a D and a C in the both part. But then a goldfish and parrot, that's just Mila. And the hamster is just Larry. So that's all I have to do. I just draw the information. Find A union B. A union B is everything. Okay, that is H, D, C, G, and P. What does this represent in words? It represents all the pets. Okay, all the pets they both have. Okay, all the pets they. And then A intersection B, that's C and D, and that's the pets they have in common. All right, not too hard. All right. So, practice with shading. Okay, you're going to want an eraser. You're going to redraw this a bunch of times, but I'm going to show you what I would do. A union B, okay? A union B is all of A and all of B. Easy enough, right? Not too hard. Then we have, so that one's easy. We'll do that one in pink. And let's do orange. A union B union C, well, that's everything, okay? That's all of A, all of B, all of C. Okay, that one's the orange one. A intersect B is just where they overlap. Just this part right here. Okay, so that's A intersect B. A intersect B intersect C is just the part in the very middle. It's where all three of them overlap. Okay, that's it for the notes. Hope you enjoyed it. We'll do some practice. Some parts of this are hard, so you guys should have some questions for me in class. All right, see you next time. Bye.